Good afternoon, classes. This is Mr. Holmes. Today we're going to be discussing properties of exponents part 1. So this part deals with multiplying exponents, dividing exponents, and negative exponent properties. Part 2 we'll get to later this week deals with the property of 0 and power to a power when it's in parentheses. So just to review, remember that an exponent really just means repeated multiplication. For example, if I had something like, let's just do 4 to the second power, this just means 4 times 4, which is 16. If I had something like x to the third power, this just means x times x times x. The base is your number being multiplied over and over. The exponent tells you how many times you're multiplying your base by. So in this case, I'm multiplying 4 twice. In this one, I'm multiplying x 3 times. Not x times 3, not 4 times 2. It's repeated multiplication. So there's 3 forms for exponents. There's exponential form, expanded form, and standard form. So what we're going to do, we're going to make a little table with the 3. So I'm going to use exponential form, expanded form, and standard form. And I'll also add a 4th piece, base, at the end. And now I'm going to look at different examples. Sometimes I might have a base with a number. Sometimes I might have a base with a variable. If I have a base with a variable, I'll never get a numerical answer at the end. And that's okay. But if I do have a base with just a number, I can get an answer at the end. So let's just look at the different forms. So the first form is exponential form. Exponential form just means it has a single base, a single exponent. For example, I can do 7 to the third. This would be exponential form. Base with an exponent. Expanded form means if I write it out with repeated multiplication, what does it look like? So 7 to the third is really just 7 times 7 times 7. And standard form is just a fancy way of saying your answer from your product. So if I do 7 times 7 times 7, I get 343. And my base for this is 7. That's what is being raised to the exponent. Let's look at another one. Let's do 4 to the 5th. This is exponential form. Expanded form would just be I'm taking the base of 4, I'm multiplying it by itself 5 times. So my base is 4. And if I do 4 to the 5th with my calculator, and this is how you do it on your calculator. They don't have an exponent of 5, so whenever it's an exponent other than 2 or 3, we can use this y to the x button. So what do? You type in your base first, you then hit the y to the x, and then you type in whatever exponent you want. And that's 1024. You could also do 4 times 4 times 4 times 4 times 4. But what if the exponent was 80 or in the thousands? I'm not going to do that over and over. Just hit the y to the x button. So it's 1024. And I'll put this on the side. We use the y to the x button for exponents, for any exponents. So that's the general button. I showed you before with x squared and x cubed, but this is for any general. The last one we'll do with the table is what if instead the base was a number, it's a variable now. So let's look at y to the 4th. Expanded form, it would just be y times y times y times y. It's not going to have a numerical answer, so I can't have a numerical answer with a variable as the base, so I leave this blank, and the base was y. So That's just some basic definitions. So know the difference between exponential form, expanded form, standard form, and what your base is. So it might say write it in exponential form, write it in expanded form, write it in standard form, write it as with your base. So just know the types. Now we're going to get into our multiplication property. So I'll just put a line there and continue. So let's say now I wanted to multiply two numbers in exponential form. So let's do 5 to the third times 5 to the fourth. And if I try to do that on my calculator, I could do 5 to the third times 5 to the fourth, and I'll get 78,125. So I'll just make a little note underneath it, 78,125, so we can check. What I'm going to do is I'm going to write this in expanded form, each of these. So 5 to the third is really just 5 times 5 times 5. 5 to the fourth is really 5 times 5 times 5 times 5. So if I look at it, how many 5s am I actually multiplying all together? If I count, I'm doing 1, 2, 3, 4, 5, 6, 7. So really, I'm multiplying 5 7 times. So if I write this in exponential form, this is really just 5 to the 7th. And if I do that on my calculator, 5y to the exponent 7, you get the same answer. So instead of doing each part separate, we're going to use what we call our multiplication product rule to come up with a formula how to get this. So that's 5 to the 7th, which was 78,125 if I wanted to expand it out. Next one, 4 to the 2nd times 4 to the 8th. What do I get when I do this? So this is just 4 times 4, for 4 squared, and then the other piece is 4 to the 8th. That's 4 8 times. 5, 6, 7, 8. So if I count up the 4s, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So really this is just 4 to the 10th. That's my exponential form, and if I wanted to write it out in standard form, just do that on my calculator, 4y to the x 10. That gives me 1,048,576. I could also do it with a base that isn't a number. I could do it with a variable. So what if I did x squared times x cubed? This is just x times x for x squared, and the other piece is x times x times x. This gives me x to the 5th. 5x is being multiplied. So now, do you see a pattern relating the multiplication to my final answer? I had 5 cubed times 5 to the 4th, I got 5 to the 7th. Here I got 4 to the 10th, here I got x to the 5th. Notice 3 and 4, if I add them together, 3 and 4 is 7, 2 and 8 is 10, and 2 and 3 is 5. So if you thought, oh, I'm going to add, yes, you come up with the rule. So this is my product rule. I'm going to write it out in words, and I'm going to write it out with the actual exponential form. So this just means when you multiply exponents with the same base, you add the exponents. So when I multiply exponents with the same base, I just add the exponents, base nothing happens to. So really it means this. X to the m times x to the n is really just m plus n added together. So I keep the base, add the exponents. So I just add the exponents, base stays the same. And I can only do it with bases that match. So if I had an extra number here with like a 5 as the base, I couldn't do anything with the 5, only bases that match together. So we'll look at an example with this product rule. So if I did the following, okay, examples. So let's look at x cubed times x to the 8th. So really all I'm going to do is I'm going to keep the base, add the exponents together. And that gives me x to the 11th. I could do it with more than two numbers, or more than two exponential forms. So let's do y to the 4th times y to the 7th times y to the 20th. So it doesn't matter if I have 1, 2, 3, 4. All the bases are y, so I can keep that. And then I just add the exponents together. So 4 plus 7 plus 20 equals 31. So it's y to the 31st. And then my last example. What if I had two bases with different variables? So let's do x squared y times x cubed y to the 4th. If I don't have an exponent with my base, it's just really an invisible 1. So when you don't see an exponent with it, it's really just an invisible 1. So you can always add a 1 if you don't see anything, if you want to put the 1 there. You don't have to, but I like to put the 1 there so I know what exponent it is. So we're going to use our product rule. Bases must be the same. So in this case, I have two bases, so I can add the x bases together and the y bases together. So if I do the x's first, I have 2 and 3 for my exponents, and then for the y, I have 1 and 4. So this just simplifies to x to the 5th, y to the 5th. I can't do anything more. That's my final answer. So you just stop right there. No more simplifying. Just combine all the bases that match together. And when they don't match anymore, you just stop. So that's my product rule. Now we're going to look at our quotient rule. So quotient rule. Let's say I wanted to simplify. We're going to derive it first. 7 to the 4th over 7 to the 3rd. So what is 7 to the 4th or 7 to the 3rd? So what I'm going to do is I'm going to rewrite each of these exponential forms in expanded form. So 7 to the 4th is just 7 times 7 times 7 times 7. 7 to the 3rd is just 7 times 7 times 7. Now I can simplify. Since it's division, everything's multiplication, anything on the top can cancel with anything on the bottom. So these 7s cancel, these cancel, these cancel. So I'm just left with 1, 7 on the top, nothing on the bottom. And remember, if there's no exponent with your number, it's really an invisible 1. So really my answer is just 7 to the 1st. And do you see? Remember, with multiplication we added, so do you see something relating the exponents here? 4 and 3 to get 1. We're going to do subtraction. So multiplication's adding, division's subtracting your exponents. We'll look at another one. Let's do x to the 8th over x to the 5th. And if you look, 8 minus 5 is 3, but we'll show that with the expanded form. X times 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 x. 8x is on the top, 5 on the bottom. 4, 5. 1, these cancel, those cancel, those cancel, those cancel, those cancel. I'm left with 3 on the top, which is really just x to the 3rd. And I'm done. So my quotient rule states to divide when two bases are the same, write the base and subtract the exponents. Very similar to the product rule. You write the base, add the exponents. This one's write the base and subtract the exponents. So divide when two bases are the same, write the base and subtract the exponents. So this is what it looks like. So x to the m over x to the n is really just x to the m minus n. So we'll look at 3 examples that show this. Okay, first example, x to the 5th over x squared. If I use my product rule, I could do the expanded form, and you can always do this and cancel, but it's probably quicker to use the quotient rule. Since the bases match, they're both x, I write the base, subtract the exponents. I get x to the 3rd. Done. Second one. Let's do 3 to the 5th over 3 cubed. Again, bases match. Write the base. It's division, so I subtract the exponents. 5 minus 3, that's 3 to the 2nd power, which also could be written as 9. Exponential form, standard form, it will let you know which form it wants you to write it in. Either one's correct. And let's look at one last one. Let's do x squared y to the 5th over x y cubed. So notice this one now has 2 different bases. It has an x and a y. So again, same thing. It doesn't matter how many different variables are written, only simplify bases that match. First thing first, the x. There's no exponent, that's really an invisible 1, so I'll write a 1. Look at the bases, okay? So I'll start with x. So these two have an x, and they're both being division, so I subtract the bases, or sorry, the exponent, so 2 minus 1. And then for the y's, they're being divided, so their bases match, so I subtract the exponents. Now I simplify. 2 minus 1 is 1, so that's just x to the 1st, and 5 minus 3 is 2, so it's y squared. And you're done. So that's your quotient rule. Now we're going to get into negative exponents. What if I had on the top, instead of 5 and 3 on the bottom, what if I reverse it, put 3 on the top, 5 on the bottom? I'm going to get a negative exponent. So what is a negative exponent? So if I make a table, and I'll do this quick, let's do 2 to the 4th, 2 cubed, 2 squared, 2 to the 1st. If I do this on my calculator, 2 to the 4th is 16, 2 to the 3rd is 8, 2 squared is 4, and 2 to the 1st is 2. Okay, now let's look, what if I wrote negative exponents now? So let's do 2 to the negative 4, 2 to the negative 3, 2 to the negative 2, and 2 to the negative 1. Okay, let's do this on the calculator. So 2 to the negative 4, so I do 2, y to the x, 4 negative. So I type 4, then I hit the negative sign after. If I hit it, I get 0.0625. Okay, let's see if I can make this into a fraction. So if I hit second, the arrow, that's 1 over 16. Let's look at 2 to the negative 3. 2, y to the x, negative 3. That's 0.125. As a fraction, that's 1 over 8. 2 to the negative 2. 2, y to the x, 2, negative 2. I get 0.25 as a fraction, that's 1/4. And 2 to the negative 1, 2, y to the x, negative 1. That's 0.5 as a fraction, that's 1/2. So do you see a relationship relating a positive exponent with a negative exponent? I do. Notice it's basically the same thing, they're just reciprocals of one another here. The 16 here is now in the bottom of the fraction. The 8 is in the bottom of the fraction. The 4 is in the bottom. The 2 is in the bottom. So a negative exponent really just means you're going to have a fractional answer. it's 1 over that exponent. And I'll show you this now using a expanded form with two numbers. So just take into account this relationship, what it means, these numbers, these answers. So let's look at this. So I should just title this, okay, negative exponents. Okay, so let's start. Let's do 4 to the third over 4 to the 8th. I'm going to write this out in expanded form. So 4 to the third is just 4 times 4 times 4. And 4 to the 8th is 4 times 4 times 4 times 4 times 4 times 4 times 4, and one more, 8 fours. And again, if I simplify this, these 4 cancel. I have 5 extra 4s on the bottom than the top. So really, this is just 1 over 4 to the 5th. If I use my other rule, okay, the quotient rule, remember, to divide when two bases are the same, write the base, subtract the exponents. So I'm doing 3 minus 8. 3 minus 8 is really negative 5. So 4 to the negative 5 is really 1 over 4 to the 5th. How are these related? A negative exponent becomes positive in the opposite part of the fraction. This is always true. A negative exponent becomes positive in the other part of the fraction. So now I'm going to get to my rule for negatives. If it's negative in the top part of the fraction, it's positive in the bottom. If it's negative in the bottom part of the fraction, it's positive in the top. So let's write out my thing. I'm going to a new sheet of paper. Rule. Okay. So x to the negative m is really the same as 1 over x to the m. Or 1 over x to the negative m is the same as x to the m, or x to the m over 1. So this is an easy way of thinking about it. Move to the opposite part of the fraction. Flip the sign of the exponent. That's all you do. You don't change anything else. When you have negative exponents, the only thing you're changing is the exponent sign. Nothing else changes. Just move it to the opposite part. Notice the base doesn't change. It's still x. The exponent itself doesn't change. Only the sign changes. Negative to positive, negative to positive, positive to negative. So let's look at some examples here, how to apply it. First example, 6 to the negative second. I'm going to rewrite this without a negative exponent. So the first thing, if you're ever stuck, write it as a fraction. So if you're stuck, what I like to do is I just like to write it as a fraction. So in this case, my negative exponent is in the top part of the fraction. So when I rewrite it, it has to be positive in the opposite part of the fraction. So all I do is I move it to the opposite part of the fraction and change the sign of the exponent. And now the top's just 1. So now it's just 1 over 6 squared. And if you really want to simplify it, you can just say 1 over 36. But this is all you do. Whatever part of the fraction it's in that's negative, you rewrite it in the opposite part of the fraction and make it positive. So all you do when you have negative exponent, make it positive by moving it to the opposite part of the fraction, and then use your rules. I like to do this first before then I do the quotient or product rules. Just move it, make it positive, and go from there. Second example. Let's do a to the negative 4. In this case, a to the negative 4. Right now it's in the top part of the fraction if I rewrite it. So to make it positive, I move it to the opposite part of the fraction, which is the denominator now. Change the sign, and it's 1 over a to the 4th. And another one with a single exponent. Let's do this. Two over 3 to the negative 2. Okay, here you got to be careful. The only thing I move is the pieces with the negative exponent. If it doesn't have a negative exponent, leave it alone. So in this example, I leave the 2 alone. This is really just 2 to the 1st. I don't care about this part because it's already positive. Leave it alone. The only part here I have to worry about is the 3 to the negative 2nd. So I'm going to leave the 2 to the 1st alone. Since it's negative in the denominator, to make this positive, I move it to the numerator, the opposite part. So I put the 3 and make it positive 2. And that's my answer. 2 to the 1st, 3 to the 2nd. Don't move the 2 to the bottom. Only move the piece with a negative exponent to the opposite part. That's all you do. Okay, let's look at a couple other ones. This. Here we go. Let's do k to the negative 5 over k squared. So there's 2 ways you could do this. I'm going to recommend one over the other. The way I don't recommend, first way you could do, you can use the quotient rule, just subtract, then rewrite it. But our goal is we want a positive exponent. So whenever I see a negative exponent, I'm going to rewrite it with a positive exponent. So first thing I'm going to do is rewrite everything with only positive exponents. So the k to the 2nd is fine right now. I'm going to leave that alone. K to the negative 5. Oh, that's negative in the top part of the fraction, the numerator. So to make it positive, I move it to the bottom part of the fraction. Now it's 1. And now I can use my rules and simplify. So 1, and now k squared k to the 5th. Since it's all on the same part of the fraction, I can use my product rule, which is really just keep the base, add the exponents. This just becomes k to the 7th. How many k's are there altogether? There's 7 k's being multiplied. That's my answer. Next one. 3 to the 3rd times 3 to the negative 6. If it helps, write it as a fraction. The 3 to the 3rd I'm going to leave alone. That's positive. 3 to the negative 6. Negative exponent, don't like. Negative in the top means positive in the bottom. So I move it to the bottom part of the fraction to make it positive. And now I simplify this. 3 cubed over 3 to the 6. I can use my quotient rule, subtract, or just think. Which part has more 3's and by how many? This really is 3 3's. This has 6 3's. So I have 3 extra 3's in the bottom than the top. If I use my quotient rule, it's really just 3 minus 6, which is 3 to the negative 3. And then I just rewrite this as 1 over 3 to the 3rd. Remember, negative in the top means positive in the bottom. Or if you don't want to do this, just think. Once I have it, everything with positive, just think, which part of the fraction has more 3's and by how many? And then that is the part of the fraction that becomes positive. Since I have more 3's in the denominator than the numerator, it's going to be positive in the denominator. And there's 3 extra 3's. So if you don't want to do this, you can just use that idea. Last one we'll look at. 2 to the 4th times 10 to the negative 6 over 2 squared times 10 to the negative 2. First thing I'm going to do, rewrite everything with a positive exponent. So the 2, I leave alone. I leave this 2 alone. 10 to the negative 6. Since it's negative on the top, it's positive in the bottom part of the fraction. -2. Since it's negative in the denominator, it's positive in the top part of the fraction. Now I simplify. Since I have the same bases 2 and 10 in different parts of the fraction, basically I just need to figure out how many more of each are there in which part of the fraction. So I can use my quotient rule, subtract, or I could just see, in this case, there's more 2's on the top than the bottom. And that's 4 minus 2 is 2. So I have 2 extra 2's on the top. And in this one, I have more 10's in the bottom than the top. And this is by 4. 6 minus 2 is 4, or 2 minus 6 is -4, and there's 4 extra in the bottom. And I leave it, and that's my answer. And that's all you do when you deal with negative exponents. Again, negative exponent, whatever part it's negative in, to make it positive, move it to that part of the fraction. Nothing else changes. Base stays the same, exponent stays the same, just the sign changes. Okay, let's just see, looking and see if there's anything else I need to add. I think that's good. I think that's everything you need to know for this first part of the video. In the second part of the video, we'll get to our zero exponent rule, our power rule, expanded power rule. We'll go into more details. But again, this concludes the part 1 of the video on how to multiply exponents, divide exponents, and negative exponents. Again, it's all about matching the bases and using your properties of exponents. This is Mr. Holmes signing off. Enjoy your rest of the day and take care. Bye-bye.